Hello everybody, welcome to the third video for the cumulative review packet number 11. We're going to start here with number 14. And both of these are from first semester. This one's just solving an equation, so let's see what we get. If I want to get x alone and figure out what x is, I'm going to distribute in this 1/5. And remember that multiplying by 1/5 is the same as dividing by 5. So 1/5 times 10 over 1 is technically 10 over 5x minus 15 over 5 equals 14. Distribute that negative, minus 4x minus 20. 10/5 is the same thing as 2x. 15 divided by 5 is really 3. So 2x minus 3 equals 14 minus 4x minus 20. These are like terms though, so we could say that this side is really negative 4x. 14 minus 20 is minus 6. So now if I want to get the x's together, I would add the 4x to both sides. So I'd have 6x minus 3 equals negative 6. Add the 3 to both sides. 6x equals negative 3. So be careful. Make sure then if you divide by 6, you would get x equals negative 3/6, or even better, negative 1/2. So my answer for number 14 is negative 1/2. And you could take negative 1/2 and plug it back into the original equation to see if both sides are equal. Number 15, when you have a fraction equaling a fraction, that is when one diagonal must equal the other diagonal. And so this really is a cross multiplication, something that I know will be helpful for you next year in geometry. So what this is really saying is negative 2 times 8x plus 2 would be equal to negative 4 times 2x minus 1. So if I distribute over here, I would get negative 16x minus 4 equals negative 8x plus 4. If, like number 14, I now want to get the x's together and I add the 8x over here as a possibility, I will get negative 8x minus 4 equals 4. I then would add the 4 to the other side. So I would get negative 8x equals positive 8. When I divide both sides by negative 8, my answer would be x equals negative 1. And also, just like number 14, if you took the negative 1 and plugged it back into the original equation, both sides should be equal. 16 and 17 are asking, or telling you that you have two functions, the f function and the g, and it's telling you to perform the order of operations. Remember that the symbolism here means that I'm taking negative 6 and I'm plugging it into the f function, and I'm taking the 4 and I'm plugging it into the g function. These are just names, so you know which one I'm talking about. The 5 in front is multiplying whatever answer I get. So what I'm going to do on number 16 is I'm going to leave the 5 alone for now, but I'm going to focus on taking the negative 6 and plugging it into the f function, which is 3 times x, but now my x is negative 6 minus 2. So that would be negative 18 minus 2, or negative 20. However, I still have that 5 in front, which means I need to multiply my answer by 5. So the first part, I get an answer of negative 100 because of 5 times negative 20. Now the second part, if I take 4 and plug it into the g function, x squared minus 6 times x, this times x is 4. So we'd have 4 squared minus 6 times 4. I would simplify that and get 16 minus 24, which is really negative 8. But there's a 3 in front, which means that my answer I got for this needs to be multiplied by 3, so that's negative 24. Now I'm not done with this problem yet because it's telling me to add my two answers. So if I took the negative 100 plus negative 24, my final answer would be negative 124. Number 17 is a different notation somewhat than 16. What this means is that I'm plugging my negative 2 into the innermost function first, or f. So I'm going to leave my g, but I'm going to take negative 2 and plug it in for x into the f function. So 3 times negative 2 minus 2. So that would get me negative 6 minus 2, or g of negative 8. Now I'm not done, because now I need to take negative 8 and I need to plug it into my g function here, so wherever I see an x. So instead of x squared minus 6x, I would get negative 8 squared minus 6 times negative 8. Negative 8 squared is a positive 64. Just like the quadratic formula, actually, I have two negatives, so that really is a plus 6 times 8, or 48. So if I add 64 and 48 together, that would be 112. So my answer here was negative 124. My answer here was 112. 18 and 19. Solve the following system of equations. Again, this is something I know will help you in geometry next year. We want to write our final answer as a point x comma y. So if I look at 18 and I want to solve this system, because they are both in standard form, I'm going to solve this one by elimination. And 19, because a variable is solved for already, I'm going to solve this by substitution. So for 18, if I want to use elimination, I need to figure out which letter I want to get to cancel out. I'm going to work on the y's. I'm going to multiply this equation by 2, because I want this to become 6. And I'm going to multiply this equation by 3, because I want this to become 6 also. Notice that the signs are already opposite of each other, so we don't have to do any negatives out here. So if I distribute those in, I would get 8x minus 6y equals negative 58. And then I would get negative 21x plus 6y equals 123. So now that my y's combine to be 0 and cross out, I would combine down. And when I do so, 8 minus 21x is negative 13x equals 123 minus 58, which is 65. Now if I divide both sides by negative 13, I get x equals negative 5. However, I still need to find y. So I have to take that negative 5 and plug it back into one of the two originals. I'll plug it into 4x minus 3y equals negative 29. So that would be 4 times negative 5 minus 3y equals negative 29. Negative 20 minus 3y equals negative 29. Add the 20. Negative 3y equals negative 9. So if I divide both sides by negative 3, I get y is 3. So my answer as a point would be negative 5, 3. And again, if you take that answer and plug it in for x and y in both equations should be true. Number 19, because y is already alone, I'm going to substitute this in for where I see a y in the second equation. So the second equation will become 4x minus 5 times y, which is negative 4/5 x plus 10, and all of that still equals 30. If I distribute in the negative 5, that is not multiplying. We'll worry about the 4x later. This is really 5 over 1. So negative times negative gives me a positive. 5 times 4 is 20. 1 times 5 is 5. So we have 20/5 x. Negative 5 times 10 is minus 50 equals 30. 20/5 is really 4x. So we have 4x plus another 4x minus 50 equals 30. If I add the 50 to the other side, I would get 80 over here. And if I added these together, I would get 8x over here. If I divide by 8, I get x is a positive 10. If I would like to find y, I'm going to plug it back into this one. Y equals negative 4/5 x plus 10. So if I plug this 10 in for x, negative 4/5 times 10 plus another 10. This is really 10 over 1. So I have negative 40 over 5 plus 10. Negative 40 divided by 5 is negative 8 plus 10, which is 2. So my answer as a point would be 10, 2. And again, feel free to check that if you want to make sure it's right. Last problem from this semester was during the exponents unit, and this is graphing an exponential function. So we use a table just to remind ourselves of the exponent rules. What we're really doing is taking these values and plugging them here for x. So that would be 1/2 to the negative second, 1/2 to the negative first, 1/2 to the 0th, 1/2 to the first, and 1/2 to the second. If we think about our exponent rules here, the 1 and the 2 are being raised to the second, so 1 squared over 2 squared would be 1/4, or 0.25. This is really 1 to the first over 2 to the first, which is 1/2. Anything to the 0th is 1. These two have a relationship because one exponent is positive and the other one is negative. You might recall that negative exponents have things flip. So if this one is 1/2, this answer would be 2 over 1, or 2. And these two have a relationship. If this answer is 1/4, the reciprocal would be 4 over 1, or 4. And you can definitely plug that into your calculator to check, but my goal here was to remind you about the reciprocal. And so what I'm going to do is graph these 5 points. You really have, for instance, -2, 4 as a point, and then plug in -1, getting out 2, plugging in 0, getting out 1, plugging in 1, getting out 1/2, plugging in 2, and getting 1/4 out, or 0.25. So -2, 4 is here, -1, 2, 0, 1, 1, 1/2, and then 2, 0.25. So my graph is going to come down. You might remember the word asymptote, which means you're getting really close to something. So it looks like this graph is getting really close to 0, but not touching it. So now if I look at my graph or my table, I notice that my y-intercept is at the point 0, 1. The asymptote is the line that I'm not crossing, and I'm not crossing the x-axis here. And because it's horizontal, it always has to be y equals a number. The number that y equals here, or cannot cross, is 0. So y equals 0 would be the line I cannot cross. The domain represents really represents all my x values that are possible. And if you look to the left, the graph is going to continue all the way to the left, and the graph is going to continue all the way to the right, because remember, you're thinking left to right. So my domain would be -infinity to +infinity with parentheses, because I can't actually touch that number. Some of you might remember that was the answer for all exponential domains. My range is the y values instead, and we go from the bottom to the top. So if I start my cursor down here, it looks like the first y value that my graph is getting close to is the same as the asymptote, which is 0. Because I can't touch 0, the first part of my range would be a parenthesis 0, because I can't touch that. And then if I keep going upwards, it looks like my graph from there continues all the way towards really high y values at infinity. So my domain is from all the way to the left, -infinity, to the right, +infinity, and my range is from 0 all the way up to infinity. If we take a look at our graph, it looks like from left to right that my graph is rapidly decreasing, which means that this is exponential decay. All right, guys, thank you for sticking with me on the videos. I hope they were helpful. Good luck on your future test.